So the other day, I looked at Twitter and I saw this tweet from Sean, also known as Swix, and he said something like every open source dev infra company needs a separate control plane from data plane if they want a viable cloud business. And this super resonated with our experience, and it raised a lot of questions like how what other companies, is it really so specific to open source dev infra, or other what makes a company needs this, what goes here versus what goes there, are the requirements, what are the challenges, are good architectures that solve it. So I invited Ram, who everyone in the channel already knows. I'm not even doing an introduction at this point. And I invited him to really walk us through. He built control planes before. When are they needed? What do they require? What they have to do? And how to build them? And why is it kind of hard? And okay, here's the thing. The reason we're so excited about it is that the stealth companies that we're building is actually doing something pretty amazing specifically for control planes. So we would basically love to chat with you. If you feel like you need one, if you're actually absolutely convinced that you will never need one, we want to talk control planes with you. So ping me, I'll put all my contact details below, and let's have this conversation. So with that said, handing it off to Ram from here.
Thanks, Gwen. Yeah, so when I really saw this tweet, I was super excited because honestly, my experience building Confluent for the last 6 years, I was able to really empathize with the statement here. And then we, as some of you might know already, we have left Confluent and we are starting this company. And one of the things that our platform would really help out is in like building this control plane. But what I thought was this is probably a good point to kind of discuss. Why is this thing about control plane and data plane even relevant in the first place? What use cases they even apply to, and what does typically the architecture look like, and why is this even hard, right? Why are we even having this conversation in the first place? So let me start with going over when is this relevant, right? Like when is this whole notion of control plane, data plane relevant? So the first thing, as mentioned in the tweet, is open source infrastructure starts with the data plane, right? Which is typically a company or a set of engineers build some product, they open source the code, they start building a community around it, and largely the product is focused on the data plane aspects of it. So, for example, a database like MongoDB was really focused on providing MongoDB, functionalities in the open. Kafka, which I was part of, we built Kafka, the messaging system, in the open source for a long time, and built a very successful community around it. Now, what happens after this is typically these open source systems gain a lot of traction, and then what happens is they want to really commercialize the system. They wanted to provide it for a lot of customers across the world at scale, and provide this infrastructure as a service. And typically, when you get to the point where you want to provide it as a service, there'll be a bunch of requirements which makes you have to build a control plane. We'll talk about what those requirements are, but open source infrastructure where you start with the data plane and eventually move into like the cloud is a very classic example of this. But having said that, in my experience, this is not limited to open source. This is where uh, any infrastructure that you're trying to build, be it open or closed, uh, comes into the picture. Which is, this could be like a data system, like your databases, or you're providing some kind of a metadata system, like a data governance system. All of these store data for your customers, and then they provide a bunch of operations on top, and these are called data systems. This could be any security infrastructure that you're building, like fraud detections, or any kind of certificate management and so on and so forth. And these are classic examples of platform or infrastructure features that you're trying to build. Developer productivity is another great space, typically where if you're building a CI/CD product, you're building some kind of a tool chain that internal developers can leverage. They all have to be provided as a service, and that brings in a lot of complexities that we'll talk about. In all these cases where all these verticals where you're trying to provide a product as a service, you do end up having to think about where does your data plane reside, how do you control the life cycle of all these data plane and your product for your customers. So, but what is common between open source and closed source, and why do I say that it is not specific to open source? Now, as I said, there is a natural progression in open source where you build the data plane and then you end up trying to think about it as a service. So control plane being a separate thing makes sense. But there are also a lot of other reasons in the infrastructure and platform um, space when you're providing it as a service. And there are a few key reasons. The number one, uh, not in any particular priority order, but one of the reasons is cost. Now, if you think about it, you typically are providing an infrastructure which could be high throughput, which means it could be very network heavy or data heavy. In such cases, you essentially it's going to be very expensive for you to move this data from wherever the customer's cloud and region and VPC is to your own VPC, which could be another cloud provider or another region, which is substantially expensive. And network cost is one of the top most expensive thing in the cloud. And usually, what you want to do is, do you want to push the data intensive aspects closer to where the customer is? In this particular case, this could be a specific region, specific VPC, and
I
this could
think
be a
I
reason.
saw the other day two guys on Twitter arguing what is more expensive, and like it was the multi-tenancy context, but yeah, is compute more expensive and therefore you want to make that multi-tenant, or the data more expensive and that should be multi-tenant? But it's very clear that the really expensive part is the network, and no tenancy shenanigans will overcome if you have need to move data between two regions, or even worse, between two clouds.
That's right. That's right. And we had some interesting experiences with that at Confluent. The second thing is security, which is due to a lot of compliance and regulation requirements from the customer side. um, they typically might want their data to be in a specific geo, like this could be the US, the European Union, or Asia, Asia Pacific. And in some cases, they might be even particular about the who gets access to this data, which could be only the customers, employees, which means this could be even in the VPC, right? But security plays a huge role in determining where your data plane resides. The another important point is performance, which is can be which will be obvious, which is you know throughput and latency. When you want really high throughput, you want to be as close as possible to your customers' applications and services. But also latency is another factor, which is if you're actually building a really critical mission critical application, leveraging a specific infrastructure or platform, the last thing that you want is to have a round trip from India to the US, which kind of doesn't make sense. So you essentially have to move the data plane closer to uh, the customer's services, which means that you'll have to manage these data planes across different regions and different cloud providers wherever the customers are. Another important aspect is high availability and scale. So, high availability is extremely important in cases where you're again running a mission critical application or platform, and you essentially have to make sure that you don't get interrupted with network connections and timeouts when customers are trying to leverage your platform or services. And some other times you're going to have to shard your data because of the massive size of the cluster, and you have to manage multiple such clusters, which is also another reason why you could end up having multiple such data planes in different regions and cloud providers. And finally, even if all these points don't matter, companies end up acquiring other companies. You end up having different um business units and sometimes in different cloud providers, and you end up having to leverage a common platform, um, which means you need to have the presence of your data plane in multiple cloud providers. So kind of all these reasons um, are kind of pushing you to an architecture where you typically have a lots of data planes deployed in different regions, in different cloud providers. Now the VPCs could be either fully hosted on your side for the customer VPC, or this could be in their own account, um, depending on the security requirements. But what you have to do is a single customer will have a lot of their clusters spread out across different regions and different cloud providers. At the same time, multiple customers across a user base will have their clusters across different regions and cloud providers. So how do you end up managing such a massive fleet of systems at the same time being able to satisfy all the customer requirements that we just talked about?
And I think it also makes sense to highlight that you not just have to manage the fleet for yourself, you actually want to give like a single pane of glass for your customers to manage their fleet using your control plane, essentially, which is what makes it difficult. Otherwise, I would just set up Terraform and be done with it.
Exactly. Yeah, I think the single pane of glass for your customer uh, is kind of a obvious thing. You have to provide a single place where they can go and manage all their clusters. Um, this is a good segue into the next point, which is we talked about what could be the requirements of a customer, but then it's also useful to talk about if you have to build something um, of something that supports these requirements, and you want to provide your infrastructure or your platform as a service, what would be you know what should be in this product as a set of requirements, right? And the first thing that comes up is lifecycle management of your data plane. So if you think about it, in all these cases, what do you have to do? The user needs to be able to pick the location where they want their data plane. Typically this could be like, hey, I want it in a specific geo or in a specific cloud provider in a specific region, uh, sometimes even in a specific VPC. And users end up picking all these things. They'll pick a set of capacity for data systems, um, and then the system has to be able to orchestrate and deploy the clusters in that specific uh, location. And then you need to, after that, manage the entire life cycle of the infrastructure, which is how do you do updates, how do you delete, how do you expand, and so on and so forth. And this kind of are called basic control plane APIs, typically, that manages the life cycle of your data plane. Um, the
I
other,
think maybe
you know,
even before that, just a step back, because I was thinking about it. Not every data product or infra product has a website. Like you need a web application so in which customers can do all of those things. So maybe like I don't know, requirement zero is you need a web app, and this web app should allow customers to do one, two, three, four.
definitely. So, in fact, this is true for all the requirements that we are going to talk about. Is anything that you have to do and the customer has to interface with your product has to be from a single pane of glass, which kind of means you need a basic web application that they can get access to. So the next requirement would typically be that the customer, as Gwen is pointing out, needs to be able to choose a specific region, a specific cloud provider, sometimes even a specific cloud account. And how you do this, again, this could be through your dashboard, this could be through your CLI, this could be through APIs. uh, and This is a necessary requirement for any of this platform and infrastructure products that are being provided as a service, complying with all the requirements that customers need around cost, security, and so on. Uh, the third requirement, and very basic stuff, when you have a web app where you're trying to manage a specific customer, you fundamentally need to have multiple tenants or organizations, each organization or a tenant mapping to a specific customer. Sometimes in really large companies, they might end up having multiple business units, each one being mapped to a specific tenant or organization. Um, and Each of these organizations will have hundreds and thousands of users that you will have to manage within the context of the organization. And that's pretty important. And you need to be able to do all of this through your UI like any other SaaS app, right? This is no different for an application SaaS or an infra SaaS. You kind of log in, you kind of look at all your organizations that you're part of. You need to be able to, provision a cluster within a specific organization. You need to be able to give access to a specific user. So this all falls under the bucket of organization and user.
Because we're talking about infra, it's not even physical users. It can be the API keys that you use to integrate with GitHub, kind of user. So
Uh, and Few obvious things which are required but more important in an infra SaaS uh, use case is you need to obviously bill your customers for your business. And typically, this could be a combination of providing a subscription based option plus usage billing. And usage billing makes a ton of sense for a lot of platform and infrastructure product in the cloud. And This is something that becomes, again, a very table stakes for your SaaS um, application. And the next one is security policies. We talked about how security is such a big deal, especially for mid market to enterprise segments. And within the security policies, there's lots of things. It's a pretty massive topic, but basic things from access controls, RBAC, uh, provide defining quotas for which organizations and which tenants, and who can enforce, who can do which users get what quotas in a more granular way if needed. Governance policies around GDPR, where the data resides, what do you do when the data gets deleted, and even things like privacy aspects. Such a big space and really really hard typically to implement in the context of SaaS and your infrastructure product. But guess what? Your infrastructure product does not sell, honestly, if you don't really have these things in your product, because you know the expectations of the quality and the security bar for a platform or infrastructure is definitely really high.
for startups, even when they are tiny and only have like three people, they sell to very large enterprises. Like we know, you know, the two-person startup, but that because they did build such a powerful and useful, they had this open source community already. They closed deals with a large bank, and more than that, a large bank in Europe.
Yeah.
So suddenly, a three-person startup has to navigate financial regulations in Europe, which is kind of a heavy lift in best of days. I was saying, do you want to talk about the
Yeah.
challenge of applying this at high throughput? Because that was a specific concern around security policies.
Yeah. So I think one of the things with a data plane and a control plane is if you think about RBAC, you need access controls for your control plane operations as well as your data plane operations. And if you have to apply access controls for your data plane, how do you do that? So typically, the control plane has all the source of truth, and you need to be able to make sure that for high throughput and low latency requirements on the data plane, you have a system that can propagate all these controls to your data plane, and you need to be able to cache that information and enforce those policies on the data plane side, making sure that there is still low latency and high throughput capabilities on the data plane side. It's a complicated problem. We'll talk more about that in the architecture section. And finally, I think integrations with other back office systems is another important criteria. This is probably not obvious, but even for a very early stage company, you have very basic requirement like, if a user signs up into your organization, you might want to essentially create a campaign in, let's say, Marketo. But there are also things like, imagine if the user decides to delete the account, you don't want to continue sending campaigns to them, which is kind of a common issue that you see in most SaaS products. Or even more important thing is, imagine if the user decides to suspend or delete their account and you continue to bill them, you're not going to have really happy customers. So these are use cases where you need all your back office systems to understand the data in your control plane, and also execute actions based on what the user executes through the APIs or UI on the control plane, and make sure that data is always consistent across all these different systems. Anyways, that's plenty of requirements that we have already spoken about. And you know, we don't want to go over more requirements. I think there's already a lot of
Requirements are
things that
always endless, especially when
contemplated.
you're talking with a product manager.
Yeah. So what I think and this is a good overview of the things that we just spoke about and the requirements on what a control plane does and what a data plane does. As I mentioned, a bunch of things on the control plane side.
Yeah, I don't know if we need to spend
Yeah.
tons of time here. It's just kind of what
Yeah.
fits
And then on
where.
the data plane side, these are things that you already should be aware of what your product does, right? So cool. So let's move on to the architecture. This initially is going to be a little overwhelming. Um, but if you look at, and I'm zooming out here, um, now what's presented in this architecture, if you look at it, the thing that's marked in orange is what we define as the control plane. You on the right, you have all the things that the customer interacts with. You have the UI portal, which is a single pane of glass that talks to your product. You also have a customer VPC on the right, which is in gray, that typically, for this purpose of this discussion, we have Kubernetes as a cluster management system. And then you have your own cluster deployed on Kubernetes. This could be a data system, a security infrastructure, like fraud detection. This could be, again, a developer productivity tool, and so on and so forth. You have a local agent. I'll talk about that. I'll come to that. But it does a set of things usually around managing your cluster deployment, reporting usage, and executing some local commands that the control plane request it to do. So that's on the right, which is all customer focused. And if you look at the extreme other side of the control plane, you have the back office SaaS, which is largely around all the systems that you have in your company that all the other stakeholders like your sales, marketing, data scientists, and everyone use to run the business, but also the things that you use to, you know, run campaigns with your customers, and things that you do that are also customer facing. And those are things that typically integrates with your control plane, and a lot of the business are driven through that. So for particularly around the architecture, let's first focus on the control plane and see how the control plane satisfies all the requirements that we just spoke about. And then we'll talk about how it needs to work with the data plane and, like the back office aspects, to essentially have a complete system that actually works for your customer and for your company. So, if you look at the control plane here, uh, we have a bunch of services you typically have to build around, user management, your org management and tenant. uh, you have access controls like RBAC. uh, Billing and pricing is another aspect that we just spoke about, and I'll talk about how all this gets um, powered from customer data. You have cluster management, which is a very core functionality of a control plane, which manages the life cycle. And then, in some products, you might even have things like SKUs that define which tenant or organization gets what features, uh, depending on what SKUs they have chosen in your product, right? So
It's combination of billing and access
yeah,
controls, I guess.
yeah. And finally, you also have an analytics system with exposing all the usage data uh, for your customers, um, things like alerts that the customers might need to define for their product, and that also becomes core part of the control plane. And as you can see here, the control plane also integrates with single sign-on. This could be very simple things like GitHub, Gmail, or Okta for enterprise customers. And then all of these have to be exposed as public APIs for your customer. So by
Yeah, by the way, as complex as it already looks, reality is far more complex than this. Like we already hinted that RBAC and SKUs and billing work together. The analytics DB and the billing has some integration. Like we drew it as nice little boxes, but it's actually very much a
yeah,
service mesh. Like you'll have a lot of services and they all
yeah,
have
that's
to
that's an
integrate.
excellent point. And so as Gwen said, this is complicated, but that we now have to get into how do you make all this work, right? Which is typically you have a single control plane in one of the cloud providers. Sometimes due to regulations like FedRAMP, you might have multiple such control planes, but they're far and few. They'll probably be, you typically have like one at best, two or three control planes. But on the other side, the data plane, you're going to have many of them. You're going to have a lot of customer accounts. Each of those accounts have many VPCs and regions where they will have your cluster deployed. Um, this could be either the customer account or your account. It does not matter. And the UI portal that we have here on the right has to essentially interface with your control plane and the data plane side of things. And now, how does this communication between the data plane and the control plane work? So let's go over a single basic use case. Let's say you're provisioning a cluster, right? Which is typically the customer chooses the region, the cloud provider. For purpose of this example, let's assume they do that through the UI, and that gets to the gateway. Now, the gateway is going to typically go interface with this cluster manager, which manages the metadata of the cluster and the state of what's happening to the cluster. For example, is it deployed? Was there an error while deploying from the cloud provider? Um, and so on and so forth. So that data gets pretty much usually persisted in a DB. But what's more important is now this is an asynchronous call. So typically you return back to the UI, basically providing a state saying, processing in progress, let's say. And then the changes from this metadata gets propagated to your data plane, right? And when that gets propagated over, a local agent on oh before I even say that, a very important point here is that propagation has to be your tenant and um, cloud provider and region aware, which is that particular propagation has to happen to the right region and the right tenant, because if you propagate it to a wrong customer, you're essentially leaking data, or you're going to deploy the cluster in a very wrong customer's VPC or in a completely wrong location. So you need to make sure that the routing happens appropriately. And once the local agent, which we talked about, which runs on the data plane side, receives this change, it needs to take some action. And what action does it take is, if the cluster does not exist, it's going to essentially deploy the cluster in this particular case. um, and once it deploys the cluster, and the deployment can be of different mechanisms. This could be by using Terraform. This could be by calling another AWS service or another cloud provider service. Um, let's assume for this purpose of the discussion, that is something that uh, we figure out, right? It's not, I wouldn't say it's easy, but it's something you'll have to do. And then once that provisioning happens, it needs to essentially return the state back to your database saying that the cluster is successfully deployed, or was there a failure, or whatever response that the cloud provider returns, or whatever status that you want to show, that gets propagated back to your database. And once that happens, the UI automatically updates its state by querying the cluster manager service and getting the most recent update on the cluster state. Now, as much as I mentioned all of this have to happen in a timely way. You can't expect your users to wait forever. I have seen products where you provision the cluster and they actually send you an email the next day, sometimes even multiple days when the cluster is ready, right? And in modern days, in a self-serve world, uh, that's kind of a joke. You're not expected to do that. You have to do all of this in a significantly less amount of time. So reliability.
What do people expect these days? Is it like 10 seconds, 10 minutes, an
Yeah, I think,
hour?
in my experience, there'll always be these 99th percentile where you'll have outliers. But on an average, people expect to get their cluster in a minute. People already get a little frustrated when you say 3 minutes. And then over a period of time, we continue to optimize it. Remember one thing, from a business perspective, the number of clusters that fail to provision is a revenue loss for you. Because what happens typically is when users try out your product and things don't work immediately, they tend to leave. So this is very important even from a growth perspective, that your clusters get created instantaneously and people get the service that they expect to get in a very timely way. So which brings to the point that this whole propagation mechanism has to be extremely resilient, and you cannot lose these events. It also has to be low latency, that it needs to get through this entire workflow quickly. And one other final thing that I'll mention is failure scenarios have to be handled really well. So imagine that you propagated this event, the local agent consumed the event, and for whatever reason, it deployed, it executed the deployment step and then crashed. When it comes back up, it needs to understand which clusters are ongoing, right? And what it will typically have to do is to reconcile with your control plane. So the local agent will typically have a cache, which essentially gets populated and bootstrapped on startup from your control plane, from your database, gets the most recent state, and then start. That's kind of the reconciliation step, and then starts executing from that point onwards. The other thing to note here is, um, the agent also does, uh, after deploying the cluster, as I said, um, it also needs to provide you some level of metrics. So it's not just the state, it will also have to provide you some level of metrics around, did you deploy it, and is the cluster even running actively? So imagine an health check being executed locally, and you need to know the metrics of this health check, because if you really are saying a cluster is truly healthy so that the customer can start using it, you need to know that the cluster was launched and healthy. So the metrics around all these services that you have locally for health checks will also get propagated to the control plane, which then gets propagated to your customer as well. So that's kind of one workflow that we just spoke about around provisioning a cluster. The other thing to note here, which I think is the red and orange lines here, is around the the direction of communication, is that all the data plane calls happens from the data plane to the control plane, which means the connection gets initiated by the data plane and then data gets transferred. This is really critical for security conscious customers, but even if you're not security conscious, this is the best practice, because what's very important here is the data plane is highly protected, and only the data plane can initiate connections and decide on what actions to execute on, and not the other way around. So even if one the events that it gets from the database, it initiates the connection, establishes a connection, and then starts consuming all the changes from the control plane. So anyway, so that's kind of on the data plane side. And you can think about this is actually even more complicated, because typically what happens, as Gwen was mentioning, um, there's also things like metrics that gets pushed from the data plane to the control plane, and that data has to feed into not just your cluster management to figure out if your cluster is healthy, but also like your billing to essentially charge your customers. You might have to sometimes also, depending on if the customer has decided to delete their cluster, um, based on that usage data, you might have to stop the billing, you might have to suspend the account, and so on. So a lot of interdependencies between all these services on the control plane and what happens on the data plane side. So on the left hand side, as I mentioned, the back office integration is also something that has to work synchronously with all these things that are happening on the customer side. And I'll just mention a few examples. I don't want to go too deep into this, but imagine if a user uh, signs up and they create a new organization, you need to be able to start sending campaigns to them to make sure they can get onboarded and successfully use your product, which means you need to have integrations with Marketo. You might have a use case where a customer comes through your sales pipeline. You create an account, a deal gets closed, and you want to create an account in the control plane, um, to make sure that the user can go now through the UI portal and start using your product. If you don't have,
And even like we created the cluster, like having some of the usage or even status of the cluster, like because we are sending if the cluster healthy up all the way to the control plane. If it goes to Zendesk, you can get a ticket, or if you call support, they can actually see what is the state of your clusters, which would otherwise be a slightly uncomfortable conversation if no one in support can actually
yep, very
say
good point.
anything.
So again, so lots of integrations. There's also the data warehouse where what happens is you need to make sure the pipeline is always stable. You don't break things if something gets broken on your control plane side. Um, this used to happen a lot till we really stabilized it at Confluent, and it's a hard problem because typically, uh, just the database to the data warehouse is already hard, and sometimes what happens is you end up also pushing the data from your data warehouse to other systems, and then you have this problem where a marketing person identifies something is broken, and then you have to backtrack and figure out what really happened in production that caused this breakage. So
And it's worthwhile saying that if you're confused why we need a data warehouse and an analytics DB because you still try to do all your analytics on the data warehouse, we have a previous video with Ram where he talks about his view of the data world and explains that data warehouse has certain personas as a result certain capabilities, and analytics DB serves different use cases and different
that's right.
personas.
Cool. So this is kind of the high level architecture of what gets goes into building a platform or an infrastructure as a service. And as a final, to conclude this conversation, I want to like basically highlight a little bit on what are the hard parts in building something like this. Uh, so
I mean, I don't know. It's such a simple diagram. Why would any of it be hard, right?
yeah, so to start with, everything is really hard about this. In my experience, it is easy to go build I wouldn't say even it's easy, but it's relatively possible to go build a quick prototype. But making it actually work with all these different systems and disparate parts, different cloud providers, different regions, security controls, cost requirements, and everything makes it pretty hard. And specifically, if you think about it, we talked about how the SaaS table stakes uh, is in itself a lot of work, which is things like your user management or your billing aspects, and so on and so forth. And it's also more complicated because you need to have this mesh of all of them talking to each other, because there's lots of SaaS flows that have to interact with each other, right? And I think I didn't mention this, which is very interesting. I wanted to mention it here. Like, when a typical simple action, like a user gets, an organization gets suspended, let's say, where how do you make an org suspended when they don't pay you for X month? And something like that requires you to like make sure you uh, monitor the usage, make sure that you stop the security aspects of the cluster so that it cannot take more requests, make sure you stop the billing of the cluster. And that is a simple example of a suspended organization. um, and there are a lot more SaaS flows similar to this around onboarding and security and so on, that makes you have to like build a lot of tight mesh between these services. The other thing to note, uh, I think it would be clear by now, is the control plane and data plane integration is a can of worms. Making sure the control plane can orchestrate across all the regions, push the events in a more reliable and low latency way, make sure the communication happens in both sides, and connection gets initiated only from the one side, and all this happens reliably and you don't lose any of these events, uh, is tricky and complex. And getting this right is hard. And then soon enough, what happens is when you have a lot more clusters, you get into like scalability challenges, which makes it even more interesting challenges.
And we only talked about it from the customer perspective, but if you think about something like upgrade, and you think, how would you know what percentage of your fleet got upgraded? Control plane has to be
Yep.
able to answer
Yep.
those questions. What percentage of upgrade failed? You need to be able to answer those
Right.
questions.
And the next one, I think, is, as you said, back office integrations. This is the most ignored part of a company's system, which is they're usually untested. There is no on call. There is literally nobody who's testing all these things that actually work. So they're pretty fragile. You end up breaking arbitrary pipelines. Um, and I think a lot of conversations have happened here around data mesh, ownership, and so on and so forth. But I also think in the SaaS world, and especially the flows we are talking about, they're not even async, they are actually synchronous. So in some cases, you might actually have to have a billing system where if you don't integrate with your back office billing system, what happens? Do you actually call somebody and do you get support? Um, can you make sure that there is auditability across this entire pipeline for your billing system, and so on and so forth? So it gets complicated. Now, granted, some of these are early stage problems, and some of them you know, are problems that you would face as you grow. Uh, the other thing that to note here is building a globally distributed infrastructure. No matter what the system is naturally hard. In our world that we just spoke about, there's control plane, there is n number of data planes, there is back office systems. Just making all these things work end to end is really hard. And added to all of this is typically we end up using a lot of SaaS services out there. So making all of this reliably work is generally very hard. I can give you a very simple example. A few incidents that we had where the entire front end went down had nothing to do with any of the systems that I spoke about, what was to do with our feature flag service becoming unavailable. And nobody would have expected that to prevent our UI from working. But these are very simple use cases, but they're actually distributed system problems. And they're globally distributed because the flag that I'm talking about, feature flag service, is probably in another cloud provider uh, in another region, while our service was running somewhere else. So there's an inherent challenge to distributed systems, and especially that is globally uh, that needs to be globally accepted.
It's such a classic distributed system problem because, like, the definition of a distributed system is when a service you didn't even know exists takes down your service, and more realistically, and it takes you about a day to figure out how
Yep.
in the world did that even
So,
happen.
the final thing I want to mention is doing all this in a reliable, secure, and in a low latency way is again hard. We've spoken about a few challenges in all of these cases. So yeah, I think it's generally a pretty hard problem. I find it shouldn't uh, be this hard, but unfortunately, uh, infra SaaS and platform SaaS have had their challenges. And if anybody typically are looking at their open source product or thinking of building an infrastructure SaaS product, uh, you're going to essentially think about an architecture. You want to think about it from a control plane first model, because honestly, this is probably required from day one, where even if you have two customers in two different regions, you'll end up having to do this. And most of these customers for platform infrastructure are security conscious, cost conscious, and so on and so forth. So anyways, so if you're doing this.
Yeah, I think that's actually a really important point to stress. A lot of companies, they have, when you're a startup, you have several really strong engineers. Those will typically be the experts that you have on your data plane. That has to be high throughput, high compute, interesting machine learning. Like, those are the hard problems. And then you take someone who is maybe more junior, maybe a full stack engineer, maybe someone who does not have the exact experience you're looking for, usually a generalist, and tell them, go build a control plane. And unless they really did it before, they may really struggle. We've seen teams struggle and fail for many years, and we've also seen the opposite. The teams that have the experience and did it before are usually do something very successful in a fairly short amount of time. And in that sense, so short amount of time, as I'm talking about, still 10, 20 engineers for 6 months is considered short in this world. So the key thing is that if you have this junior person who did not build this architecture before, does not know how to secure it, you don't want to really risk security leaks, breaking the customer trust, availability issues. Have him come talk to us. Like, we have a SaaS developer community for a reason. This is something that you can see me and Ram are super passionate about. We would love to educate you, brainstorm, consider different scenarios and problems we haven't really thought about yet, because everyone only sees their own problems and the problems of the 20 customers you talk to, but there's probably a bunch more out there in
Yep.
the world. So definitely don't, this is not the right thing to YOLO, because your business reputation depends on
Yeah.
getting it right.
And yeah, as Gwen said, we're building a platform that we think can significantly simplify this. If you're interested, do comment on under the under this video on YouTube, or join the community. We'd love to, have more conversations around this topic.
And this is a safe time to talk to us because we do not have anything to sell at this point.
Thank you. Yeah.
Thank you.
How long was that?